All right, so write isosceles. I'm going to shrink this and go back to my camera.
I hope I want marks on my paper.
So we can lock this length pretty easy. Whatever. Now, I see some of you guys on your papers have like kind of essentially made the whole circle. Yeah, I don't know. Might be beneficial.
Why not?
So I don't know that. So I guess the length out here would be equidistant. Maybe that's beneficial. What else? Any other ideas? How can we make, if it didn't have to be right, how can we just make an isosceles triangle?
Do the same thing. Connect it to any point.
Yeah, you do
Connect it to the edge of the circle.
So wait, what?
Oh yeah, you can just stretch it out to any point and then connect to the last one.
Stretch it out to any point.
Except like
Oh, so if we, I think what they're saying is if we made this line, it's isosceles. It's not an isosceles right, but if we connect this, it's an isosceles.
Oh, so we go to the top of the circle.
How do we know it's the top though? Right, like that versus this versus like.
We go to the corner of the circle.
So I think we know if we can get a line. Hold up. Guys, remember, this is going to start to piece things together. If we can create a perpendicular line here, and then stop it up here, it's going to do what we want it to do. My first suggestion would be extend GH out to the other edge of your circle. Sorry, I need a real straight edge. I would extend GH just because.
I'm testing something.
You're forgetting things that we did last week.
Just like literally extend it.
Well, the thing is,
Yeah, or you weren't here last week.
so no one can blame me.
So we know that length is equal. So I'm going to call this H prime. Just as a reference point for us. Now, crap. Sammy has my papers, but if I come look at what we did last week, there's one. Oh, okay, you're just doodling.
Hey, I tried to figure out how to use the compass, and then it helped.
We
Now I
did.
can use the compass.
We did a couple situations that involved perpendiculars, right? How did we do that? How did we make this little like eyeball thing that made the perpendicular?
That was I'm doing things. I don't know if they're right, but
Everyone do some things that you don't know if they're right. Play for a minute.
Are we trying to make a
Think
right
back to this. Yeah. We're trying to.
I did something
No.
that might work.
You don't have a protractor even. If I need to throw it across the room, I will. But
This
nope.
person,
I mean, you can use the straight edge of the ruler, but you can't measure any lengths. You don't have a ruler. You have a
What
straight
happens
edge.
if we didn't know but I need this length?
You have the compass to do that.
Sophia has
No, you have the compass to do that. To operate locked lengths.
I've done something that might work.
Sophia has. Sophia, don't tell me everything you did, but tell me one thing to do.
Well,
Let Sophia
I
talk.
made arcs, so with the middle on, so from the point on H and G around and then
Put the point on H.
and then put it on G and make an arc.
Put it on G and make an arc.
Yeah,
An arc from G.
from G, yes.
So we're gonna make another circle, or at least part of a
Yeah,
circle.
It needs to go outside of the circle that you have. Yeah. And then so you do the same thing but from H prime.
Wait, no. The next step.
Sure.
I'm looking at her paper.
Yeah, so you do the same thing from H prime.
It's fine.
And then if you go up to where the two arcs intersect, one of the intersections at the top, and then just make arcs from there, then they'll eventually intercept in the middle.
What?
Look at her paper. It didn't.
You're trying way too hard, girl.
But it
Girl.
worked. It worked.
You just
It
went,
worked.
girl.
Boy.
Wait, I want
You
to.
want me to boy
Oh,
you?
thank God.
It worked,
I'm thank God. I want to rewind that and just play it like a Get
So hold on. Sophia's gonna have me arc out here, and then out here, and but wait, didn't we lock a length like this, but instead of keeping it the length, we went a tiny bit bigger?
Yeah.
Because when we went a tiny bit bigger,
It did a circle.
we get that, and then, hold up, from H prime, we have the same length still locked. See my eyeball thingy?
Giving me some vertigo trying to focus on it with the light changing and then like it.
Sorry, so I'll talk it through, not drawing and turning things in. I went point on H, and I made some new, let's say, K. I locked in the length HK, and I arced. I flipped my point over to H prime, still locked in with length of K. Or length of HK, right? I arced from H prime, length K.
Could I please have Peyton march to the remote office? Peyton march.
And I arced there. This intersecting point and this intersecting point. Now, truth be told, what Sophia did would have worked. This is just quicker.
It did work. I lined it up.
Sophia was right. Someone was like, yes, but no.
Well, so that's the difference between me just saying, oh, okay, sure, that works, and here's the best way. The most efficient way to get perpendicular lines is open up a length a tad bit bigger than what you're actually working with, arc, find the intersect. But before we were able to do this, we had to drop our H prime so that G was actually our midpoint, right? Because this is actually our perpendicular bisector of H prime, but we don't care about any of this. We just care that it's perpendicular here.
It looks very pretty though.
Well, I know. I mean, if you want pretty stuff, go get the spirograph. I love spirographs. So we know this length of GH and this length of G, let's go ahead and just call this I or something. We know those lengths are equal. That makes our isosceles. We know this is perpendicular. That makes our right. So now to make our triangle, we just have to give it the third side.
Wow.
So now, oh crap, this was supposed to be labeled T. We'll call point I point T actually because they said GHT. So that point is called it, or I, or T, or whatever. So at this point, if I tossed a pop quiz in front of you, you should be able to, from part A, construct an equilateral triangle.
Oh, wait, how would pop quizzes work with math?
How what?
Would pop quizzes work with math?
I don't. I always tell you guys when but if like I was like, and now we're gonna take a quiz on this right now. You should be able to do equilateral triangle. Yeah. Look back at this and ask me questions if you have any from last week. Because it was last week, it was a while ago.
Right isosceles?
This is right isosceles, what we just made.
Okay, and I remember how to do the equilateral.
So then you should be able to construct an altitude.
Construct the end center of...
Okay, we're not there yet. Go back and look at B. Make sure you remember how we constructed the altitude. I can do it again if we need to, because my paper's blank, because y'all lost yours. Sammy, can I borrow this paper back? Just remember what we did.
I think I remember it.
It was very confusing. These are really...
Well, it also helps when you can stop and pause the video.
So
and think about
here's,
it.
hey, go back to B. Look at B. This length, MR. That's the first length we lock. Now I could have left my compass either way, but I'm going to turn my compass like this. Put that right there. Now we could have also how we did it last week. Just to remind you,
Is
we just arced it like
Oh, well,
this.
doesn't.
Yeah, that's what
Yeah, maybe it is.
I think I.
What? But not this.
Sorry, it's because because I didn't really do this right.
Why is it different?
So here's the difference. This is MR here. This is MR here. Here's how we choose what we're doing. We want an isosceles triangle. We can find the midpoint of the third side, where this is going to be the distance that we split. So we're going to use this point.
And connect that point, and then wouldn't
Yeah, and
you go-
hypothetically say this connects at least for now.
And then wouldn't you go like use like this R and the point you just made, and do two half circles more than you think would be half, and then that that
Yeah,
when they intersect is
go
the
somewhere that
line.
you think is half, bigger than that.
And then do the same with the other one, and then it intersects and makes the midpoint.
Somewhere, well, same distance, right?
Yeah.
This has to be same distance.
But then that's where it intersects the midpoint, and then use the straight edge to connect it with the answer.
Now here's the real what will work. The length, hey, stick with me for a minute. The length of MR being a length that we have locked doesn't matter. We could have locked some other length. All that matters is that we arc across this bottom line. So if I go shorter than MR, right, and I end up with these points. Crap, sorry, my paper's getting dragged a little bit. This is still the midpoint of these 2 points. Hey, you with me? Even though that's not length R, this is the midpoint of these 2 points. It's also the midpoint of these 2 points. Now, it's not the midpoint of RJ because we don't really actually care about that. But we needed it to be able to be perpendicular.
RJ's irrelevant.
Any questions? Because if we try to do it from a different side, we might have to extend one of these sides to do this first arc a little bit different. So then we did C, angle bisector. Are we good on how we did that?
Angle
You
by.
didn't do that one.
Oh, we did not
I think
finish?
so.
Crap. Okay, so look back at C. What do we have? Oh yeah, I think we ended class saying like, what if we did, what if we did.
What if we
So you've got a couple drawings on this, but I want you guys to pick this back up. Like dive in right there.
and try and do C?
Yeah, how do we angle bisector P?
So wouldn't you use the protractor?
No, we don't have a protractor.
Hey, what are you
But
talking about? Sammy, we're in like 2 BC or something. We don't have protractors. This doesn't exist either.
How do we have a compass without a protractor?
Because we are innovative.
A compass is actually a really simple thing.
Yeah.
It's 2 sticks that
So
you
is
can
a
lock a length.
protractor.
Yeah,
Protractor isn't that
Protractor is literally the letter
It's
D.
not that complex.
What have I done?
Oh no.
This is why I don't like these things.
What you doing?
I have a good idea.
Mine's a mess.
So what'd you go straight? So you just went straight down from M.
Yeah.
What? Why can I not do this?
David, you hold it there. Wait, how?
How do you know like? How do you know that's the
Sophia, do you
midpoint?
know what you're doing?
No. Because you do this like more than on each side. Where are those circles? Oh, these big circles. So then you know that's the midpoint of M because it connects
Yeah,
with
but
that
what if
one.
it's like down here?
I don't know. I'm confused by the question. Do you want me to help you make a straight? Here, David.
No, look at what I'm doing. Look at me.
David, if you angle it like this, it helps. No, it doesn't jump as much.
That's a oh.
No.
And that oh.
No.
That is big mistake.
There you
Do
go.
X and R then.
So from P, what if we, I don't know, we don't have to lock the length of PX, but it might look good if that's the length we use. What if we just add an arc to here
That's what I did.
at length PX?
And
Made
then
a big mistake.
And then what, Athena?
I don't know, but you showed us like this little picture thing at the end of class, and there was
you
like
showed
two
us the diagram.
little marks on like top, but I don't know how to get to them. That's the thing.
If only we could use whatever the scribbles do.
If only we had internet.
Wait, I think I might know how to do this.
Whoa.
You've done steps 2 and steps 3.
See, that's what I was thinking. I just don't know how to get there.
Step 4 and step 5, so stick with me. Step 4 and step 5 are pointy point on one of these intersections. It might be point X, it might not be. Make an arc somewhere. It could actually be over here, but we'd like it to be out here because the closer you are to your start point, the more likely there is to be a mistake.
Does it matter if where it is?
So that's for my pointy point. Now, this length, you could set it as anything, but I can't change my length now because I already made one arc. I need to come up to my other
Wait, did I
intersection.
actually think this through how you're supposed to do it? Wait, because I started, so I figured that because if you make one with X, then you have the 2 points
Wait, what
on
did
the
you just do?
circle, making
Now
that
there's
the
an X.
same. And then
What in the world? Wait, he made one line.
Wait, but this is outside?
You made one line, and then you made another. How did you make the
So
other?
this is step 1, and you can label it 1 if you want. It doesn't matter what length it is. I could actually make it shorter and just have it right like that.
How did you make the third line?
Step, the next steps, sorry, and I know mine's kind of hard to see. Pointy point on here, some length, doesn't actually matter what length. Make an arc.
wait, I got a question.
Keeping that same length locked, move your pointy point. I'm coming back. Move your pointy point. Arc to intersect the first arc.
I got a question.
Yes.
So,
But I'm getting 2 different results here, so I've goofed up one of these at least.
that's why I'm wondering about mine. So I did.
Okay.
You want to see what screws it up?
And
Can I show you one thing that is probably the thing you're wondering? Here's what breaks this. And literally in this situation we just did, I broke this. This arc's too big. My arc I labeled 1. You do not want to go past the vertex of your triangle. So if I'm working from P, the first arc that I keep saying, oh, the length doesn't really matter. It doesn't, but it needs to be smaller than X. I accidentally made it slightly larger, which screwed everything up. So when I made this arc, it was a little bit closer. Watch, I'll do it again. Watch, so this arc, this is my number 1 arc.
I was not doing what you
Here are my next 2 steps. Arc in here,
Okay.
arc from this point. Now, because I did those right, these should actually line up. And that's a lot closer. Okay, send it.
I'm so confused about what you're doing, but I get kind of what I'm doing. So, I did an arc from P to X and made a half circle like that. And then I saw the other point that kind of went with the other point that intersected PR, and then I used those 2 points to do the archy thing.
Here, I'll do it up here and I'll color code it. How about that?
What? I'm confused about what I did though.
I know, but I'm trying to show you the right way that we have to take.
Oh my, what in the world?
What?
pointy point.
But I'm wondering if mine works or if it's completely wrong. Like, because I made that, and then that intersected this, and I made a
Yeah.
point, and then I did it there, and I did it there. And then would
As
that
long as
work?
this arc isn't too big. Why don't you try again? Why don't you just do it again? So if you make another arc smaller to start,
Okay.
then you arc from this pointy point.
Why are you doing it that way?
It doesn't. You could go this way, but that's like really close to my vertex. So I'm just gonna go out there.
Okay.
Either it'll do the same thing, and then from this pointy point, should be essentially the same place, which it is. It's essentially the same place. That
Okay.
line.
So I did it
Yep.
right, just did
It works even if you go back towards the vertex.
I don't get it.
Here.
I sort of get it.
I
I
wish
did
I
it, and I thought about it all the way.
Sammy, can you like just save me? What?
All right, here. This kind of looks like the triangle that we have.
No.
Kind of.
I know.
Here, this actually really looks like the triangle we have. PXR, right? PXR.
I'll explain if you don't get it after he does it.
Wait, what is the point?
Be the angle bisector of this one. So you want
Is this X?
So here.
No, that's all.
Angle bisect.
Yeah. So these are the same.
Okay, watch. I drop my pointy point on the vertex, which up here is really hard.
Supports.
I open this. Crap, I forgot that place. To
Oh.
any arc length. I'm going to color code this.
I was
My black
my
arc, so my first
protractor
arc.
told me the angle.
Okay?
My compass
So we just make an arc.
told me
Okay,
the
that's
angle
number
and
one.
the distance.
Then we move our protractor to lock on at that intersection. I'm going to change my color. And those arcs
Oh my.
right? So we should have 3 arcs. One that creates 2 intersection points. And then from there, we make the green arcs. Then, the one last step is we grab a line from that point and hit that intersection point. That's how you make an angle bisector. Because, guys, what we really did here was we made an isosceles triangle. Yo, give me your attention for a second. What we did first was made an isosceles triangle. Imagine drawing a line connecting those 2 points. This distance is equal to this distance. I know I'm drawing little arrows, but those are 2 equal distances. So these points are like the legs of an equilateral triangle, making this the third leg, essentially where that intersects the midpoint, right, of the third leg. If we had a ruler, you could measure there and find the midpoint, but we don't.
What?
We don't have a ruler. We have a straight edge.
You're drawing a bunch.
Does this make sense now?
Yes.
We've not progressed as far as I need to, and that's okay. We're doing pretty well this year. Constructions are always something that we kind of struggle with a little bit. So now that we know how to angle bisector,
Do you not get it? You want me to explain?
I get it.
Okay.
Sammy's good at explaining.
So what I did was I made like X and P, and then I made like a circle. So and then you see like it intersects this point and this point on it. So then I made like an isosceles. So like just so these are the same, and then I used a random distance from here and did like the 2 arcs. See, because now I have an isosceles, and then I made the 2 arcs.
can I do it again and show it to you guys again on a different triangle? Check it. Come here to D, part D here. Watch it. I'm going to angle bisect G.
How this works?
Watch, it starts to go fast. Guys, the only way to get good at this is do more of them. Watch. From G, I'm going to angle bisect it. So first, I arc at any size. But that has created 2 intersecting points. Now, this triangle is already isosceles, but if I connected these, I'd have a new isosceles triangle. Right? From those points, either towards the vertex or not, it doesn't really matter. Sammy went towards, I go away. We arc, and then from the other point, we arc. The intersection of those two arcs is the point I need to line up with from my vertex.
Liang is.
I think it was a different distance.
So now, actually, what I've done here is bisect my hypotenuse. So another way to find a midpoint of your hypotenuse is do this, because now we've actually split this into two congruent triangles, right? Side angle side would justify these are congruent triangles. Does that make sense? Hold up. Let's look real quick because I have 2 minutes. Let's think real quick. See if we can think about any ideas. Circumcenter and in-center. What does circum mean? Around. What does in mean? Within. Right? Within. So, circumcenter. And then I want to leave you guys with, can you think, can you figure out how we would make one of these? It's actually not. Well, okay, yes. The circumcenter, sorry, I listened to what you said and processed it differently. The circumcenter is the center of the circle. But it's the circle that goes around your triangle. The in-center is the center of the circle inside the triangle. Now the orthocenter, and this I got not really an argument, but I got kind of frustrated with my sister over the weekend because I said, yeah, there's this game, you score it orthogonally. I was talking about a zool, and she was like, orthogonal? You make that word up? And my sister's an artist, right? So she should know like different words that mean like angles and lines. And like I was like, no, like are you messing with me? Orthogonal, like perpendicular, like of right angles. And she's like, nope, never heard it ever. Orthocenter comes from like utilizing orthogonal, meaning it is all your perpendicular lines, which means they're all the altitudes. The orthocenter is the point that connects all your altitudes. All of these, here, you might want to write this down like on this back page before we get out of here, because we're going to pick this up again tomorrow. These are called points of concurrency. I forget how to spell that right at the moment. Yeah, I think so. I think it's spelled like money. I was just trying to double check, is it spelled like money?
If not, then I still know what it means because it's like
Points of...
What do I do with these? Do I just...
Yeah, it's spelled like money.
Wait, I spelled it right. That's weird. Do I just put this in here?
So these are your points of concurrency. And then the centroid. Yo, we'll talk about this eventually. The centroid connects all the angle bisectors. Just so you know the other one. Now the centroid is actually the center of balance. Which is kind of fun because you can actually put a triangle on a point and it'll balance the triangle. Like literally weight balance. Maybe we'll try that. Find the centroid of a triangle and then test its balance.